All right, so we're going to start a new topic today, and it's all about solving trig equations. We've been working with identities and different uses for these values in the unit circle and all that kind of stuff. Well, today we're going to kind of bring it all together and talk about how to solve equations with trig functions involved, right? And so solving equations basically means finding an angle measure that has a particular value. So, for example, here 2 sine x equals 1, right? I want to figure out what x is. That's what we mean by solving an equation, a trig equation, right? Well, first, I can't begin to figure out what that angle is until I know what the sine value is supposed to be. And the only way I know that is to get the sine by itself. So I'm going to get sine x by itself. Divide both sides by 2, and we get sine of x is equal to 1/2. Okay, so now I know that 1/2 is a value on the unit circle. And I want to go figure out what angle measure has a sine value of 1/2. Now, think about that for a second. First of all, sine is positive. Which means that we could end up in quadrant 1 or in quadrant 2. Because those are the 2 quadrants that sine is positive, right? Well, where is sine 1/2? Well, 30 degrees is one place where sine is 1/2. If you look at your unit circle, you're going to find that 150 is also a place where sine is 1/2. So which one is our solution? They actually both are. We're going to have 2 solutions for these, right? Because we're going to have 2 angle measures that have a positive or a negative value for whatever trig function we're looking at. Okay? Now, take a look at this. Over here in the coordinates. If you were to, I don't know if we should talk about this yet or not. Let's say we didn't know what angle measure the sine was 1/2, right? Then we'd have to get into trying to get x by itself. Ripping this sine off to get x by itself. And to do that, we have to take the inverse, right? Remember this from the first unit and then geometry, right? We have to inverse sine 1/2. And that would tell you 30 degrees. But it wouldn't tell you, if you were to type this into your calculator, your calculator would tell you 30 degrees. As long as you're in degree mode, by the way, you got to be in degree mode. It would not tell you the 150. That's where we have to use our brains a little bit. Because we know that at 150, sine is 1/2. So how do we get there if our calculator is not going to tell us? Well, if you notice, the fact that the angle was 30 degrees this way is coming off of the x-axis, the horizontal. It's coming off the horizontal. And the fact that 150 is another angle where sine is 1/2, that angle is coming off the horizontal as well. It's just a difference, right? It's the negative x-axis. So the 30 degrees is coming off the place where it's coming off the horizontal where we're at 0 degrees. The 150 is coming off the horizontal where the angle measure is 180. But they're coming off the same distance. Both of these angles are coming 30 degrees off of that horizontal, right? In the case for quadrant 1, we're just adding 30 degrees to 0 and getting 30. So this is our theta. This is our answer, right? On the other hand, in quadrant 2, we're coming 30 degrees less than 180. So if we take 180 minus whatever theta is, which right now is 30, then we would get 150. So when our calculator gives us 30 degrees, we're in quadrant 1, and we know that quadrant 2 gives us the other angle measure, then we can just take that 30 degrees and subtract it from 180 and get the other angle measure. Okay? So that's how we get those 2 answers. Now, we haven't discussed quadrant 3 or quadrant 4. We'll bring that into the discussion as we work through more problems. Okay, hopefully that makes enough sense. All right, next problem. Looks like this. So again, I can't figure out what theta is until I have cosine by itself. So I've got to add radical 3 to both sides. And then divide both sides by 2. So now I want cosine of some angle to be radical 3 over 2. Where does that happen? Well, first of all, cosine is positive. So where is cosine positive? Well, cosine is positive here and here. Okay? Now, we can try to type that into our calculator using inverse cosine, or we can use our brains for a second and realize that 30 degrees is where cosine is radical 3 over 2. So again, this is 30 degrees. But it's also radical 3 over 2 at 330 degrees. So that's our second answer. And again, the calculator would only give us 30. So how would you get the 330? Well, this is still our angle measure, our theta, if you want to call it that. Theta, I'm going to start to call the distance from the horizontal. If you look at quadrant 4 angle, that's still a distance from the horizontal. But we've almost wrapped all the way around the circle. So on this side, we're at a distance from 0. On the bottom side, we're at a distance from 360. So if our original angle is 30 degrees away from 0, or 30 degrees, that means in quadrant 4, we need to be 30 degrees off of the horizontal that measures 360. So in other words, we got to take 360 minus the angle, and that'll give us the quadrant 4 angle. Okay? So just kind of a little sort of pseudo formulas that help us get to our second angle measure. All right? Next one. Looks like this. Now, trig functions are just like variables. You can combine them. You can subtract them from other sides. You can, as long as you have like terms, you can combine like terms. So here, I'm going to subtract tangent theta from both sides, which does get me into a like term. 4 tangent theta minus tangent theta is 3 tangent theta, which is going to be equal to 3. Let me divide both sides by 3. So tangent theta is going to be equal to 1. Okay, all right. So let's go over to our coordinates here, our quadrants. What quadrants are tangent positive? Well, quadrant 1 and quadrant 3. Right? Now, specifically, what angle measure is tangent 1? And the first angle measure is 45 degrees. So, off of the, if you want to call it the 0 horizontal, we're at 45 degrees. That means back here in quadrant 3, we're still off the horizontal, which is the 180 horizontal, but it's obviously, to get into quadrant 3, we have to go beyond the 180. So we have to go 180 plus 45, which is 225. So that becomes our second solution. Okay? And that's all there is to this. We're always going off of the horizontal, never off of the vertical or the y-axis. It's always off the x-axis. Okay? All right. Another one here for you to try. See if you can't figure out the two angles. Stop the video, give it a shot, and you can start it back up and check your answers. Okay, so we just got to divide by 2. So sine of x is equal to negative radical 3 over 2. So go to your quadrants. Where is sine negative? Well, sine is negative here and here. Well, we're already not in quadrant 1, so we're not going to start in quadrant 1. So if we were to type this into our calculator, inverse sine of negative radical 3 over 2, then it would give us an angle measure. But we can just think as well. Negative radical 3 over 2 is going to get us into an angle measure that is all the way over here, which is going to be 240. So one angle is going to be 240 degrees. Now, to get into quadrant 3, we're supposed to go 180 plus whatever theta is. But the 240 is such that we've already added the theta in. If I do 180 plus theta, I'm supposed to get 240. Or in other words, I need to know the distance from the horizontal. Okay? To get that, we subtract 180. And so we get 60. So we're at a distance of 60 degrees from the horizontal. I've got to be at a distance from the horizontal by 60 degrees over here. Okay? Remember that we're supposed to take 360 minus whatever theta is. Theta is the distance away from the horizontal. So here we got to take 360 minus 60 and get 300. And those are my two solutions. Okay? It's always at a distance from either 180, a distance from 0, or a distance from 360. Is another way to look at it. Okay? All right. Now, not always so pretty, right? We're not always in the unit circle. We're not always dealing with special angles. So we've got to be able to handle that. So now we can't just think through it. We're going to have to actually use our calculator. So make sure your calculator is in degree mode. And we type in inverse sine. So we need to know what the inverse sine of negative 0.9 is. Right? We type this into our calculator. And you get negative 64.158. Now, first off, we should have talked about quadrants first. In order for sine to be negative, we've got to be here and here. Okay? Now, the fact that our calculator tells us negative 64.158. Okay? Now, remember some things. Number one, negative 64.158 is not in the interval in which we need our answer to be in. Okay? We want our angles, we want our answers to be between 0 and 360. Like in standard position, basically, right? So, negative 64.158 doesn't count. So how do we get our answers into that interval? Well, the other thing you have to remember is that when our angle is negative, we measure it clockwise instead of counterclockwise. So this would be negative 64.158. But since we can't use that as an answer, what we can use that as is a distance off of the horizontal. Okay? So, if I need to be 64, and it's not negative anymore. If it's going to be a distance, distance is never negative, it's positive. So I want to be a distance off of what would be the 360 horizontal. And I call it the 360 horizontal because that's how much you would have if you went all the way around. And this angle almost goes all the way around. It's just not quite. It's all the way around except for the 64.158. So what I can do is I can just take 360 minus my distance off the horizontal. So 360 minus 64.158. And you get 295.842. Right? Now, since that's the distance off of the 360 horizontal, I need to go a distance off of the 180 horizontal. The same amount, 64.158. So to get that angle, I have to add the 64.158 to 180. And that gets me 244.8 3.158. And those are my two answers. Okay, so it's not that negative 64.158 gave us one of our answers. It just gave us the distance off the horizontal. Another one here. Okay, that's not a unit circle value, so I've got to inverse cosine this guy. And when you type in the inverse cosine of 0.77, you get 39.65. Now, a quick quadrant analysis. Since cosine is positive, we know we got to be here and here. Nope, sorry. Cosine is positive, we got to be here and here. So in quadrant 1 and quadrant 4. So this is our 360 minus our distance. This is just our distance. So our distance is 39.65 degrees. That's one of our answers. To get the other one, I got to take 360 minus the 39.65. And we get 320.354. Okay, is that making some sense? Hopefully. Okay, one more. Stop the video. Try to solve this yourself. You start it back up and see how you do. Okay, all right, so we got an inverse tangent both sides. So if I type in inverse tangent negative 1.19, I get negative 49.958. And already I know that's not going to be one of my answers because it's negative, but it is going to tell me the distance off the horizontal I need to be. So tangent is negative. Where's tangent negative? Well, it's negative here, it's negative here. Remember, this is our 180 minus the distance. This is 360 minus the distance. And right now, that distance is 49.958. So, to get our two answers, we take 360 minus the 49.958, and then take the 180 minus the 49.958, and you get 130.04. Okay, and there you go. And so just some more to do together. Number 8. We'll do together. Subtract tangent theta from both sides. You get 2 tangent theta minus 1 equals 0. Tangent minus tangent is 0. Now we add 1. And then divide both sides by 2. Okay, so tangent is positive. Tangent of theta is positive 1/2. I'm going to do a quick quadrant analysis first. Tangent's positive, which happens in the first quadrant and the third quadrant. So when I type in inverse tangent of 1/2, $26.57. Definitely puts me into quadrant 1. So not only is this one of the angle measures that I'm looking for, it's also the distance off of that horizontal. So now I got to come the distance off of the 180 horizontal. So now I'm going to add 180 plus 26.57. And so we get 206.57. And we're done. Okay. All right. Now, for the next 3, I'm just going to let you work. So stop the video, try to solve it, and then start it back up, and I'll have it all worked out for you. Okay? And there you go. There are your two angle measures. Okay, hopefully you got that. If not, make sure you come in and get some help. Okay, if you did, try this one. Stop the video, start it back up, and check your work. And there you have number 10. So another situation where your calculator doesn't give you an angle that you can use, but it gives you a distance off of the horizontal that you have to use. Okay? And last but not least, stop the video, give this one a shot, start it back up, and see how you do. And there's the last one. All right, so if you're not getting those, you don't understand where those are coming from, please find some time to come in, sit down, and we'll go through it. All right, otherwise, try the homework. We'll catch you next time.